Hello students, hi everyone. I hope you all are doing good. Okay, good evening all. Welcome to Made Easy GTQ program. Myself Sagar Pingili. I am here with the computer organization and architecture subject. Okay, so in this session we are going to discuss the questions which are related to the computer organization and architecture subject. Okay, all right. So first question is like this. All of you just read the question and try to give the answer. Consider the following arithmetic computation performed on a 8-bit hypothetical CPU. So here 8-bit CPU given. This is the expression you need to evaluate given, where values of A, B, C and D variables given as 4, 8, 10 and 9 in decimal. So what is the result in hexadecimal? We want the result in hexadecimal. Okay students, please solve the question. Okay, here variables given, variable values given, okay, CPU type given, okay, length of the CPU and expression given. Evaluate the expression and report the result in hexadecimal. Do it fast. Please do it fast. I am waiting for your response. I am waiting. Please give the answer. Quick. Yeah, Narendra Kumar, you give the answer. I am just waiting, please. And rest of the students, those who are there in the online, who are watching live session, please give the response quickly. Yeah. Artav Chauhan given the right answer. Shri also given right answer. Very good. Already some students are given the right answers, so that let me evaluate the question, right? So here first of all, a expression given expression is A into B minus C into D. This is the expression which we are going to evaluate. Okay, here input values already given in the question. A, B, C, D values respectively given. Okay, so A value, when they mention the sequence like this, A, B, C, D and A, B, C and D and values 4, 8, 10, 9, these are the respective order of the values. So here 4 into 8 minus 10 into 9. So this is the 32 minus 90. This become minus 58. Okay, these all are there in the decimal format. Now question expecting the result in hexadecimal. Okay, so as a result is concerned, this is the negative value. Negative value is the signed value. Signed value is the 2's complement value. This is the 2's complement data. Alright. Now when you see the question, in this question CPU is a 8-bit CPU. So here 8-bit CPU given. Therefore data size equal to 8 bits. Alright. So now first of all we are going to take the binary code of 58 in a size of 8 bit. Later 2's complement of 58 is minus 58. So take 58 binary code, right? 58 equivalent binary code please. 8 bit code 001111010. You just see the value. This is 1 2 4 8 16 32, correct? 32 plus 16 plus 8 plus 2, 8 plus 2, that is equal to 58. This is the 58 binary equivalent. Now take 2's complement. 2's complement of this. 2's complement of data is negative of a data, right? So here 1's complement, add 1, 0 1 1 0 0 0 1 1. Yes, this is minus 56. Minus 58. 2's complement of 58 is minus 58. So this result is expected in a hexadecimal format. So group 4 bits, report the value. So when we group 4 bits, correct, then what will be the answer? This is C, this is 6. So hexadecimal final result is C6. Now go to the options. This is the question. In the question, answer is matching with B. So here answer is B. So how many of you given the right answer? You please examine yourself, right? If any mistake occurred while doing the calculations and conversions, okay, please identify where the mistake occurred. Okay, don't repeat such kind of mistakes in future. Okay, all right. This is the analysis of the first question. Now go to the next question. Yeah, all of you see the question and give the answer. I am waiting. Narendra and all other my dearest students, please respond immediately. Consider the following hypothetical format used to represent the data. This is the floating point data format already given. 1 bit is signed, 8 bit space allocated for BE, 7 bit space allocated for Mantissa. What could be the hexadecimal equivalent of the result in the memory after perform the following computation? So we need to evaluate this computation. Later we are going to report the final value in hexadecimal, right? So whatever the result stored in the memory using the given format, that we need to represent in a hexadecimal format. Okay, all of you please do it quickly. I am waiting for your response. Yeah, Shri and remaining students, do it quickly. Yeah, Arindam, please give the response. This is the related to floating point data representation, right? So when you know the concept of floating point format, then you are in a position to store the data into a memory, right? Do it quickly. Question clear, right? This is the computation given. Evaluate this. Okay. Later you get the output. That output you need to store in the memory using this format. After storing, report the value in hexadecimal. Yeah. Akash Chaudhary, please. Narendra, what is the answer? Deepak, give the answer quick. So as you know that in our regular class we discussed the data storage and data retrieval into the memory from the memory. So there I given only the raw data, that data we are storing into the memory, and memory data given, that data we retrieved from the memory. That is already we experienced in the regular class. But in this question they are not given the raw data, they given the expression. So we need to evaluate this expression, later we are storing the data. That is the difference, nothing else. What is the answer? Narendra, very good, right answer. Narendra, you given right answer. Yeah, some of the students are still solving the question. Okay, let me solve along with you. Right, now see this question. This is the given floating point format. This is the given expression. First we need to evaluate this expression, that is minus 32 into 3 plus 24. Okay, after evaluating this it become into 3, that is minus 96 plus 24. Okay, this become minus 72, correct? So this expression output is minus 72. This minus 72 will be stored into a memory using the floating point format. So here default storage is with normalization. Default storage is with normalization. Okay, so now take the data which you want to store, that become minus 72. This minus 72 will be converted into the binary. When we are converting minus 72 into binary, no need to take the 2's complement here. Reason, we are not storing the data in a fixed point format. In the fixed point format, negative data is a 2's complement of data, but this is floating point format, so no need to take the 2's complement here. Okay, so direct conversion is binary conversion, minus, okay, 64 plus 8, okay, 64, 32, 16, right, 8, 4, 2, 1. This is the 72 binary conversion, 1, 2, 4, 8, 16, 32, 64, right, 64 plus 8, that is 72. Alright, now store this into the memory using the normalization. So normalization concept means 1 point BBB. So this data is not in the normal format. So first of all we need to convert this data into normalization. So 1, 2, 3, 4, 5, 6. So align this data to right direction 6 times. So this answer is minus 1.001000 into 2 to the power of plus 6. Now store this into the memory. First, sign of the data is negative. Then second, biased exponent is equal to actual exponent plus bias. Okay, so here actual exponent is equal to plus 6. Here space given is 8 bits. Okay, so 0 0 0 0 0 1 1 0. Next, bias. Bias is default normal bias. Everyone knows that. When the format does not contain the bias specification, default bias we need to take, that is normal bias. So 0 all ones, right, plus 127 is the bias. Now add it 1 0 1 0 0 0 0 1. This is the biased exponent. Later mantissa already normalized mantissa 1.001000. This is the mantissa. Now store this into the format given. Store it. Sign -1, BE 10000101. This is the BE, right? Now mantissa means 001 000, only fraction, but here space is 7-bit, so 0 padding takes place at LSB, right? This is sign, this is BE, and next is mantissa. Now group 4 bits, report the hexadecimal value, right? This is 4 bits, this is 4 bit, this is 4 bit, this is 4 bit. So C290, this is the right answer, hexadecimal equivalent. So how many of you given the answer like this? You please verify your answer once again, okay, whether it is matching or not. Any calculation mistakes are there or not, you please verify. If answer matching, well and good. If not matching, you please identify where the mistake occurred in your analysis, okay. C290, yeah, Ritesh, Narendra, Shri, Anil Kumar, Sayan, Akash Chaudhary. So you all are given the right answer. Thank you so much, my dear students. Hope you are perfectly all right with the data representation concepts. Okay, when you know the concept, then it takes very less time to solve the question. Any question it may be present in the paper, right? Once you are comfortable with the concepts, you are in a comfort zone of the concept, okay, without any tension, you are in a position to answer the question quickly, like this only. All right. So C290, base 16, hexadecimal value. Okay, students. All right. Concepts comfort zone is always required. Okay, any subject you may learn, bring the concepts into your comfort zone. Matlab, translate the textbook concept into your understandable format. Okay, so when the translation occurred into your understandable format, your memory always recognizes your own patterns, so that you never forget the concept. You always reliable with your concepts, right? Okay. Now this is the next question. So actually here I am going to discuss the questions randomly, matlab not in the sequential topics discussion, you know. So you just see the randomization in the concepts. Okay, questions are also there in a random manner. Okay, so all of you read the question. This is the question given. Let me see again how many of you giving the right answer. All my dear students, please solve the question quickly. This session is actually very much helpful to you to recollect the concepts. Okay, maybe you read the concepts long back, maybe you forgotten the concepts, okay, or maybe you revise the concepts with the absence of faculty. Okay, maybe you missed the confidence. Now this is the right time again to regain the confidence in front of your faculty. Okay, you all are my lovely students. You all know all the concepts of computer organization and architecture. In the class, in presence of faculty, you know all the things. After that there is a gap between you and me, so that you are busy with other subjects, right? Okay, so you revise the concepts with the absence of faculty. Now this is the actual time where we interact each other once again to recollect the concepts quickly. So utilize this session. Fine, then what will be the answer? Let me read the question. Question is like this. Consider a hypothetical CPU given which supports the following instruction formats. Okay, in this CPU, 3 types of instruction formats given. This is the format A, format B, format C. 3 formats given. Okay, in the type A, there is a opcode, register address, memory address and immediate field. 4 fields of information given. In type B, opcode, register, memory. Again 4 fields of information given. Type C, opcode, memory, largest unsigned constant value of 1023. 3 fields given. Okay, so here hypothetical CPU mentioned with 3 types of the formats. Okay, hypothetical formats. Right, now system instruction set is 100, register file size is 58 and supports 16 MB memory space. Program contain 4 A type instructions, 2 B type instructions and 2 C type instructions. Size of the program in bits. We want the program size in bits. Please give the answer quickly. Usually computer organization and architecture questions are lengthy like this. And questions are look lengthy, but it takes very less time to solve the question. Okay, because they will explain the entire concept as a question. That's what question seems to be lengthy, but analysis and the solution takes very less amount of the time. Do it quickly. Shivam, you given answer 364. Akash Chaudhary also given the answer 364. Midmay might given answer 364. Narinder, what is the answer? So when we see the majority of voting, all are given 364, then what will be the exact answer? That we will decide now. Fine. Any guess? 364 is the answer given by all students. Atharva Chauhan also given 364. Okay, fine. Now we are going to see the analysis of this question. So here total 4 types of the formats given. Okay, now A type. In this there is a opcode, there is a register, there is a memory and there is a 12-bit immediate field. These are given fields in the instruction. What, Narinder? What will be the answer? Is your answer matching to 364? Is all given the same answer, 364. Okay. Now see. Opcode size depends on number of instructions in the computer. They given 100 instructions are in the system. Log 100 base 2, this is equal to 7-bit code. Next, register. Here number of registers given in the question 58, log 58 base 2, so 6-bit address required to address the register. Next, memory, 16 MB memory given, log 16 mega cells base 2, that is 24-bit address required. After that 12-bit space already mentioned, therefore instruction size equal to A, instruction A size equal to, right, 7 plus 6 plus 24 plus 12, that is 49-bit. A type of instruction size is 49-bit. Now go to the B type. B type of instruction given. What is their opcode? Okay, register, again register, and memory. This is the format, same story. Opcode, 7-bit opcode, register address 6-bit address, again 6-bit address, memory 24-bit address. Already we assume, we calculated according to given data. So B size, instruction B size is 7 plus 6 plus 6 plus 24, that is 43 bits. Next, C type we have. Let me take C type here. There is a opcode, memory, and 1023 largest unsigned constant. Largest unsigned value present in the field is 1023. So here 7-bit is the opcode, 24-bit is the memory, largest unsigned constant 1023. 1023 largest unsigned constant is possible when the field size is 10-bit. This is 10-bit. Because of 10-bit unsigned range 0 to 2 power 10 minus 1, that is 0 to 1023. So largest unsigned constant 1023 maintain करने के लिए यहाँ 10-bit space is required. Is it clear? So 7 plus 24 plus 10, this is 41-bit. So here instruction format C type is equal to 41-bit. That's it. Individually all the formats sizes identified. Later what is mentioned here, there is a program which contain, see this program size. Now here program size is equal to, okay, how many, 4A type plus 2B type plus 2C type instructions present. So 4 into 49 plus 2 into 43 plus 2 into 41. Do the calculations. 4 into 49, 196 plus 196 plus 2 into 43, 86 plus 82. So 82 plus 86 plus 196, that is 364 bits. The total program space is equal to 364 bits. Question is expecting the program size in bits. So we reported the value in bits. So those who are given the answer as 364, that is correct answer. Okay, you are perfect with the formats. Okay, even I consider the majority voting before my analysis, so your prediction and this actual solution both are matching, error is 0. Machine learning perfect. Okay. Naman, Ritesh, Pratik, Shri, Narendra, are you there? Are you disconnected? Please utilize the time to solve the questions. At the time of solving the questions, it will gives the background recapture of the concepts. All right. Next question, please. Students, this is the next question. Please read the question, give the answer. Yeah, students, please respond. What will be the answer? Arindam, what is the answer? Very simple question. Okay, according to me it is simple, but students' point of view, because of you are reading multiple subjects, so that retrieving takes a bit of time. Okay, try to minimize that time, then only your efficiency is up to 100%. Fine, this is the question. Consider the following hypothetical formats. So this is the format given. Sign is mentioned 1 bit, 7 bit BE, 6 bit Mantissa. This is using excess bias. Clearly they mentioned this format is a excess bias format. Which of the following data elements are out of range in the respective system? So we need to identify the out of range data elements. So which data is out of range data? Please give the answer. Akash Chaudhary, Anil Kumar, Narendra, everyone give an answer. Answer is B. Yeah, again you are comfortable in this area also, right? Here format contain excess bias. Okay, that is 2 power n minus 1. Correct? That become 2 power 7 minus 1. That become 64. 64 is the excess bias. Okay, n indicates the number of bits in BE field. Okay, this is the excess bias. Now we know the exponents range. Exponents range using the excess bias. Direct formula is minus bias 2 plus bias minus 1. This is the straightforward formula. Okay, a formula, okay, used to identify the range of the exponents using the excess bias. When it is a normal bias, there we have one more formula, minus bias 2 plus bias plus 1. Okay, so this is the difference between normal bias and excess bias exponents range calculation. I ask you to remember these two formulas. Already you know how to derive these formulas. How we generalize this already you know in our regular class. So remember this formula. Minus 64 to plus 63. This is the range of exponents. Is it clear in this system? So now what we are going to do is identify total range minus 64, minus 63 and so on, plus 62 and plus 63. These are the exponents possible. In this, you know, this negative extreme, this will be used for the underflow. This is special exponent underflow के लिए. Then this is used for the overflow, that is special. These are the two special exponents. By using these special exponents, we can represent special value 0. You know that special value 0 and subnormal data. This you can represent by using this exponent. Then by using this exponent, what we represent? Special value plus or minus infinity and NaN. These are the two different values which we can manage. Okay, and remaining exponents, see, these all are the representable data exponents. Representable data exponents. Is it correct? Now, if any, see this, if any data coming in this region, देखो, if any data is having the exponents, okay, plus 64, plus 65 and so on. So, this range of data, this area data is called as the overflow data, out of range. Out of range, okay. Now, any data having the exponents in this region, so this is also called as the out of range. You can say this is underflow data. Underflow is also out of range. Underflow is close to 0. Overflow is close to plus or minus infinity. This is the discussion related to this analysis. Now you need to identify the options, okay, where the exponent is coming under out of range. Okay, now see this. First, plus 63, this is there in the range. Next, minus 64, this is also in the range. Minus 63, this is also in the range. Plus 64, this is not in the range. This we can say out of range. So in the given options, B is out of range. So answer is B. B is out of range. Okay students? Okay, you all are comfortable? Comfortable or not? Obviously you are saying yes, because you know the data formats clearly. Any question is there in the data formats, you are in a position to answer the question. Okay, any corner, from any corner question is there, from data representation you are ready to solve the question. So you all are given right answer. Thank you all. Right? Okay. So now we are going to see the next question. Yeah, this is the question. See, all of you, yeah, Narendra, Naman, Anashri, you please read the question, and all other students. Okay, I am unable to call all the names. Okay, so don't mind. You all are my dear students only. Even I refer some of the names, you don't mind. You all are my favorite students only. This is the question. Let me see how many of you given right answer. Reason, this question is having small logic. I explained this logic clearly in the regular classroom. Right? In the regular class, I explained this concept. I asked you to mind one point. Mind one point. What is that? Whenever indirect addressing mode is there, open your eyes. मैं ऐसा बोला ना in the regular class notes or regular classroom में ऐसा बोला. Whenever indirect addressing mode is there, open your eyes to check size of the address. Remember that? याद में है क्या आपको? Please recollect. Indirect addressing mode में effective address is in the memory. Correct? So when you want to fetch the effective address from the memory, in one memory reference only one word information is accessible. Okay, one memory reference means one word accessed. So when the address size is greater than one word, then multiple memory references are required to access the word. Okay, to access the effective address. To access the effective address, multiple memory references are required when the address size is greater than the word size. You know, that's what you need to open your eyes to verify size of the address before solving the question. Are you remember this? Okay, then solve the question. This is the question given. Let me read the question along with you. Consider 8-bit CPU, support 4 GB RAM, 256 registers and 200 instructions. Okay, system supports 3 address format where address 1 uses register indirect. It's not a normal register indirect. Address 2 uses indirect addressing. Address 3 uses direct addressing. Okay, following instruction is executed in the system. This is the instruction. Is it okay? Right. This is the addition. Address 1, address 2, address 3. Address 1 is the destination. Address 2 is the source 1. Address 3 is the source 2. Number of memory references, that is machine cycles required to complete the instruction is. Complete the instruction. To complete the instruction, what we are going to do? See the opcode. This is the addition. Addition. Okay, first fetch the instruction completely. Okay, then fetch the data, add the data and store the result. That is the completion. Please, all of you, solve the question. Waiting for your response. Ritesh, thank you. Count the references. How many machine cycles required to complete the instruction? Don't be panic. Okay, don't take tension. Just read the question carefully, solve it. In this question, there is a mixed response. Till now, whatever the questions I explained, there you all are given the correct answer with a single response. Everyone given the uniform response, same answer. But in this question, there is a mixed response. Some students given answer 17, some are given answer 15, some are given answer 12, etc. Why like this? So don't miss the logic, follow the logic and solve the question. Ritesh, now it is okay? Audible? Audible? Okay, fine. Pratik. Yes. Okay, fine. So I given the enough time to solve the question. Okay, इतना time नहीं लेना चाहिए because you need to feel this as a final paper, final question. Okay, so time allocation is most important. Don't take more time to solve the question. Fine. Now let me explain this. So first thing here, indirect addressing mode. देखो, register indirect addressing mode means effective address is in the register. Next, indirect addressing mode. You know, default indirect is memory indirect is default is memory indirect. In the memory indirect addressing mode, effective address is in memory. That's it. Alright, next is direct addressing mode. Direct addressing mode means effective address is in address field of instruction. Address field of an instruction. That's it. With this logic you need to decide. Okay, so first thing, what is the instruction given? Okay, so ADD opcode address 1, address 2 and address 3. Total 4 fields are there in the instruction. Fine. Now instruction size not given, we need to calculate the length of the instruction first. So first see this. How many instructions are there? 200. So log 200 base 2. So 8-bit opcode. Next, address 1. See, address 1 using the register indirect addressing mode. This is the register indirect addressing mode. So register indirect addressing mode means address field contain register name, contain address of effective address. Am I correct? Address of effective address, that is register name. Only register name is present where the effective address is stored. So this register address depends on the number of registers, 256 registers. Therefore 8-bit address. Clarity आया? Correct. Now next please. What is the next one? Address 2. Address 2 using the indirect addressing. Okay, that itself a memory indirect. So address field contain address of effective address. Am I correct? Address of effective address. That itself a memory address. So here memory address depends on the memory capacity. So 4 giga cells are there, base 2. That become 32-bit. This is a 32-bit. Alright, address 3. Bolo, address 3 is the direct addressing mode. When it is a direct addressing mode, address field itself contain effective address. Address field contain effective address, that is memory address. Okay. Alright. So this memory address is equal to 32-bit log 4 giga cells base 2, that is 32-bit. Very nice. Very good. So now what will be the length of instruction? So see this, it is a 8-bit CPU. This is the 8-bit CPU. Therefore word length is equal to 8-bit. Word length is 8-bit. Now see, this is opcode is one word. You know, in the instruction addressing modes are implemented implicitly. By default implementation is implicit implementation of addressing modes. So opcode is one word long. Alright. Now register address 8-bit, again one word long. Then memory address 32-bit, this is what? 4 word long. Then again this 32-bit, that is what? 4 word long. Therefore, instruction size is equal to instruction size 1, 1, 2, 2 plus 4. 2 plus 4, that is 6, 6 plus 4, 10. So total 10 word instruction it is. Instruction length calculated 10 words. Now this we need to complete. Instruction execution, that is IF, ID, OF, PD, WB. OF source 1, source 2, WB destination. This is the structure, skeleton of the format, as we know this. Now if you fill this, then you may understand the final output. Fill it. What is needed? First, instruction fetch. 1 MR is required to fetch the first word of the instruction, that is opcode fetch. Decoding takes place. Instruction length decided 10 word instruction. Therefore 9 MR required to fetch the remaining part, to fetch the complete instruction. Okay, all right. Next please, source 1. Okay, see this, in the question they mentioned clearly what is source 1. Source 1 address 2, source 2 address 3. So source 1 using the indirect addressing mode. In the indirect addressing mode, first we need to fetch the effective address. So effective address size is equal to 4 words. Therefore 4 MR required to fetch effective address. After that, data is always 1 word by default. So 1 MR required to fetch the data. So effective address के लिए 4 MR, data के लिए 1 MR. Next, source 2. Source 2 direct addressing mode. Direct addressing mode means address field itself contain the effective address. So that here data fetch. Data is equal to by default 1 word. So that 1 MR is required. Okay. Now PD. PD means 1 ALU operation is needed. 1 arithmetic and logical operation, addition operation required, ADD operation. After addition, result will be stored into destination. Destination addressing mode is what? Register indirect addressing mode. So here what? Register indirect addressing mode. So here effective address, fetch the effective address. Effective address is 4 words. But this 4 words present in the register. Present in the register indirect. Therefore 4 RR required. 4 RR, register reference required. 4 register reference required to fetch the effective address from the register. After that, data store 1 MR. Data is by default 1 word. 1 word data means compulsory 1 MR is required to store the result. To store the result, 1 MR needed. Yes, this is the discussion. Correct? So total, how many memory references are required to complete the instruction? Memory references count karna hai. So memory references, please count 1. Okay? 9, 10. 10 plus 4, 14. 14 plus 1, 15. 15 plus 1, 16. Right? 16 plus 1, 17. So 17 is the answer. 17 memory references required. How many of you given 17? That is correct answer. Right? Those who are giving the wrong answer, you please verify where you did the mistake. Don't repeat that mistake again and again. Because in the regular class I explained many questions with this logic. Okay? Alright. Pratik given right answer. 17. Anil Kumar given right answer. Narendra, what is your answer? Hi DGS, how are you? Yeah, students, those who are given the wrong answers, you please verify where you did the mistake, okay? Concept you know, but the way how you are implementing the concept is very important. If the concept is missing at the time of interpretation, final answer is also wrong. So be careful at the time of implementing the concept in the current question, whichever you are solving right now. Okay, DGS, you are late to the session. Okay, fine, no problem. Question clarity मिल गया ना students? All are comfortable? Okay, fine. Now we are going to see next question. Yes, this is the question. All of you read the question carefully and solve the question. I am waiting for your response. First you read the question. Narendra Kumar, why are you giving the right answer? Why are you giving the right answer to the previous question? You are not at all given any response, right? That means, are you solving the question? Are you stuck in the logic? Narendra, please respond. In the previous question, few students are given the right answer, many are given wrong answer. Matlab, they confused with the logic. I don't know whether it is a calculation mistake or conceptual mistake. I don't know, but you please verify yourself. This is the question now. Let me read the question. In an enhancement of a design of the CPU, enhancement of a CPU design, speed up of floating point unit has been increased by 40% and speed up of fixed point unit has been increased by 20%. Floating point unit and fixed point unit speed ups are increased in the enhancement. What is the overall speed up achieved if the ratio of the number of floating point operations to the number of fixed point operations is 6:9. This is the ratio. Floating point to fixed point. Ratio is 6:9. 6:9. Next. And the floating point operations used to take thrice, 3 times the time taken by fixed point operations in the original design. Okay. So, we need to calculate the overall speed up. Then how to calculate? What will be the answer? Please respond. Yeah. So students, you please solve this question. Sayan, you are asking the doubt to the previous question. In the previous question, see, in the previous question, destination is what? Destination is the register indirect addressing mode. Register indirect addressing mode means finally result will be stored into the memory. So that's what 4 RR required to get the effective address. Later this 1 MR is there for store the result. Store the result. This is the MR, not the RR. MR. Reason, register indirect addressing mode. Register indirect means effective address is in the register. Go to register, get the effective address. Later go to memory, write the data. Sayan, is it clear? Alright. Students, please give the answer. sumo memory access in pipeline. memory access questions चाहिए. Wait. Second, you please solve this question. Sumo. Pipeline questions we will see. Don't worry. Mighty, please verify the solution. Shivam. Do the calculations quickly and give the response. This is the enhancement related question. Okay, CPU enhancement, speed up increased. Okay, ratio given, execution time also given. Execution time also given. So calculate execution time of a old computer and calculate execution time of a new computer. Later report the speed up. Okay, speed up is equal to execution time of old computer by execution time of new computer. DGS, correct answer. That's the spirit. DGS, yeah, you are given the right answer. Very nice. Feeling very happy. Very nice. Aisa Karna questions. Okay, Narendra, what will be the answer? Please respond. So I given the sufficient time to solve the question to you. Still few responses. So let me explain the solution. Narendra, you too given the right answer. Very good. Narendra, your answer is right. Fine. So we'll see how to solve the question, how to interpret the question. Right? So in this question, first thing is floating point and fixed point. देखो, number of fixed point instructions given as 6. Okay, similarly number of floating point, because they given the ratio, right? The ratio, you see this ratio of the number of floating point to number of fixed point. So number of fixed point instructions equal to 9. This is the ratio. See this, 6:9. Okay, 6 floating point instructions, 9 fixed point instructions. They give a ratio of the number of floating point operations to the number of fixed point operations. Okay, these are the number of instructions present in the system. All right. So now let us take fixed point takes x units of time, x time to complete the instruction. Then floating point takes 3 times of fixed point. They given thrice, 3x time. See, floating point operations used to take thrice of the time taken by the fixed point. Alright. Therefore, execution time of old computer is equal to old computer execution time, that is 9 instructions fixed point taking x units of time plus 6 instructions floating point taking 3x units of time. Okay, 9x plus 18x, right? 18 plus 9, that is 27x. This is the old execution time. Now, execution time of new system, you know this. Execution time of new, speed up is increased in the, so usually speed up s equal to et old upon et new. Therefore, et new is equal to et old upon s, you know this, upon s. Okay, so now see here what we are going to calculate is execution time of new fixed point. New fixed point unit is equal to, right, execution time of old fixed point unit 9 into x upon speed up increased, fixed point speed up 20% increased, so 100% plus 20%, this become 120%, that is 1.2. Is it okay? So this is 1.2. Do the calculation, 9 upon 1.2, that is 7.5x. This is the new fixed point execution time. Send execution time of new floating point. Floating point old time is how much? Old time 18x upon new time how much? New time we are calculating, but speed up increased 40%, that means 100% plus 40, that become 1.4. So 18 upon 1.4. 18 upon 1.4, that become 12.85x. Therefore, execution time of new system is equal to fixed point time plus floating point time. So this is equal to 7.5 plus 12.85, that become 20.35x. Is it clear? So now report the value. What is the speed up? S overall. S overall is equal to overall speed up. Execution time of old upon execution time of new. So this is old time how much? 27x upon new time 20.35x. So 27 upon 20.35, that is 1.32. This is 1.32. This is the answer. What is the overall speed up of the system after the enhancement? Overall speed up 1.32. According to the given characteristics, we substituted the information. We analyzed the information. Finally, we got this answer. Okay? Hope you understand. Those who given right answer, well and good. If any wrong calculations, wrong interpretation occurred, please verify where you injected the wrong. Okay, students? S. Sayan Chakravarti. This is the similar pattern of the gate question, because many students are confused with that gate solution. That's the reason I formulated the question like this. Sayan. Yeah, in the previous gate questions also this pattern question is present. Okay, many are confused with the solution. Okay, that's what I explained this again. All right, students, see the next question. Jerry Santosh Kumar, you asked me to solve the questions in IO. So in the IO organization, except DMA and interrupt driven IO, there is no numerical questions possible, right? So IO portion is very less. So there we have two options, DMA option and interrupt driven IO concept. Okay, so remaining hard disk concept is already present in the memory portion, right? Even a hard disk is also coming under the IO area. Okay, so when we shift the hard disk into the memory portion, only DMA and interrupt IO, program IO, these three concepts are left for the IO. Okay, this question you may solve easily. Santosh, do you understand? Students, what is answer? Simple concept. Consider a hypothetical CPU with 2 nanosecond clock which consumes 7 cycles for data transfer, 9 cycles for ALU, 4 cycles for branch. Okay, relative frequency is already given 50%, 30% and 20% respectively. In the system enhancement, ALU operations and branch operations each enhanced with a speed up of 3. What is the speed up of a system after the enhancement? After enhancement, what will be the final speed up? Sayan, if you use Amdahl's law, it's okay, no problem. Solve the questions quickly. Narendra given the answer. Might he given the answer right? DGS, you all given the right answer. Okay, all right. So this is also enhancement related question, right? System enhancement. First we need to calculate the execution time of old system. Execution time of old system, direct formula is there. Here we are using the formula summation of IC subscript I into CPI subscript I whole multiplied with the cycle time. Okay, so now 50% data transfer consuming 7 cycles plus 30% data manipulation consuming 9 cycles plus 20% branch consuming 4 cycles. Is it okay? The overall cycle time in this question given as 2 nanosecond. Right? So 3.5 plus 2.7 plus 0.8 into 2 nanosecond. Report this. 3.5 plus 2.7 plus 0.8 into 2, that become 14 nanosecond. Right? Now in the system enhancement they are given clearly only ALU instructions, branch instructions are enhanced. Therefore new CPI is equal to old CPI divided by S. Okay, so new CPI is equal to old CPI divided by S, because speed up given, speed up is equal to old upon new, so new equal to old upon S. So here ALU CPI is equal to old ALU taking 9 cycles upon 3, that become 3 cycles. Then branches after enhancement, branch CPI is equal to 4 upon 3. Okay, old branch instruction taking 4 cycles, 4 upon 3, that become 4 upon 3, 1.33. Right? Now use the same formula to do the calculations. So execution time of new is equal to same formula, 0.5 into 7, there is no change in that, plus 0.3 into 3 plus 0.2 into 1.33 into cycle time 2 nanosecond. This is 3.5 plus 0.9 plus 0.2 into 1.33, that is 0.266 into 2 nanosecond. So report this, 0.266 plus 0.9 plus 3.5 into 2 nanosecond, that is 9.332 nanosecond. So old execution time, new execution time, both are calculated. Now substitute them in the final speed up. Final speed up formula is S equal to execution time of old upon execution time of new. Now substitute. S is equal to, what is the value? 14 upon 9.332. 14 upon 9.332. That become 1.5. This is the answer. 1.5 is the speed up. Okay students, let me see how many of you given right answer. Sayan, Akash, Pratik, Naman, Shiv, DGS, Narendra, you all are given the right answer. Very good. Thank you so much all. And remaining students, maybe you are just watching. This is the crucial time to implement your knowledge, to enhance yourself. This time also, at this time also, you are just watching without interpreting your own knowledge, without communicating properly. That is not a good sign. Okay, so this is a crucial period. So please implement your knowledge, whether it is right answer or wrong answer. Please calculate, communicate with faculty. So if any mistakes occurred, we are going to encounter them immediately. Okay, all right. Fine. Next question, please. This is the control unit related question. So as you know that from the control unit, if questions are going to be formulated, only we have three options of the questions. One is what? Hardwired control unit, second horizontal, third vertical. So you know all the concepts, so that you please read the question carefully and give the answer. Please, all of you. Students, read the question. Question is like this. Okay. So first, what given? Consider a hypothetical hardware which contain 200 control signals, 8 flags and 16 branch conditions. Control unit supports 256 kilo control word memory. Following instructions are designed in the system. First, instruction A. Horizontal micro instruction with 8 control signals to be activated. Then B. Vertical micro instruction with 4 control signals to be activated. C. Micro instruction is designed with horizontal and vertical, where horizontal activates 6 signals, vertical activates 7 signals. Size of A plus B plus C in bits. You know, nowadays in the exam paper they are creating the complex questions. Okay, instead of giving the single instruction, they are accumulating multiple instructions in the single question. So lengthy questions they are introducing in the question paper. That is the reason I given this question to you. In this question you have a horizontal concept, vertical concept and a hybrid concept, mixing of horizontal and vertical together. Please give the answer. Narendra, you given the answer. Very nice. Remaining students, please respond. I am waiting for your response, please. Students, what will be the answer? So Narendra, you given the answer. Remaining students, please. Horizontal and vertical concept. So see this. In the question DGS, question contain 200 control signals, 8 flags, 16 branch conditions, and control memory capacity also given. These are the micro instructions we need to design. First, A type. A is the horizontal micro instruction. With 8 control signals to be activated. Now format contain BC, flag, CF, CM address. This is the format. Branch conditions, how many given? 16. So log 16 base to 4 bits. Flags, 8 flags, 3 bits. Okay. Control memory, log 256 kilo cells base to 18 bits. Alright. Now control field indicating the control signals. How many signals? 8 signals we need to activate. Okay. Even you want 8 signals activation, 200 bits space required. In the 200 bits space, any 8 bits are ones, remaining bits are zeros, because horizontal means decoded form of control signals. Even we want to activate one signal, still total space is required. Clear? So now this is 4 plus 3 plus 200 plus 18. That become 225 bits. This is the micro instruction A. Now micro instruction B. What is given? This is the vertical micro instruction with 4 control signals. See, this is a lengthy process. So here also we have the format BC, flag, CF, CM address. Okay. So branch conditions same, flags same, memory address same, 18 bit. Then difference is control field, indicate the control signals. How many signals? 4 control signals we need to activate. 4 control signals means 4 function codes needed. 4 function codes. Okay. Then what will be the function code? Function code size equal to FC equal to log number of control signals base to encoded formatted control signal. 4, how many signals? 200 signals base to, therefore 8 bit. One function code is equal to 8 bit. So 4 function codes needed. When you see the 4 function codes, 4 into 8 bit, that is 32 bit. Is it clear? Therefore second instruction size is 4 plus 3 plus, okay, 32 plus 18, 57 bits. This is 57. Now C. What is the C here? Micro instruction with horizontal and vertical. Okay. H means horizontal, B means vertical. So same format, BC, flag, CF and CM address. So branch conditions no change, flags no change, address no change. But control field represents 2 kinds of control signals. One is horizontal, second is vertical. In the horizontal we need to activate 6 signals. In vertical we need to activate 7 signals, given clearly. Horizontal with 6 signals, vertical with 7 signals. You need to design. So even you have a 6 signals, still 200 bits required. Okay. When you want 7 signals, 7 function codes needed. So 7 into each function code is 8 bit long. Right. So 7 into 8, that is 56 bits. Okay. So now value of C is 56 plus 18 plus 200 plus 3 plus 4. that is 281 bit. Okay, here 3 different micro instructions given. We identified the size of each micro instruction individually, correct? Then what the question is asking, what is the size of A plus B plus C in bits? So we are going to provide the summation of this, 225 plus 57 plus 281. Okay, then answer is 281 plus 57 plus 225, that become 563. 563 is the answer. Okay students, this is the conclusion. How many of yours answer is matched? Please respond. Where you did the mistake, identify. Don't repeat the mistake again. That's it. Anil Kumar, Narendra, Naman, Mighty, Pratik, DGS, Sayan. Yeah, you all are given the right answer. So you all also comfortable with control unit, right? So apart from the numerical, you just read the basic fundamental theory points of each control unit design. Okay, remember the differences in the paper. If they are asking any theory based question, okay, by comparing different control units, you are in a position to answer them. Fine, very good. Thank you dear students. You all are given right answer. All right, now next question please. Good. This is the question. All of you read the question. Consider the following code executed in the pipeline system. Code given and pipeline given. Instructions used in the standard syntax. Standard syntax means first opcode, next parameter destination, next source 1, next source 2. All right. These are the instructions, 7 instructions given. I1, I2, I3, I4, I5, I6, I7. Total 7 instructions given. Identify the correct statements given below. So we need to identify correct statements. This is like a MSQ based question. Okay, so all of you read the question and give the answer. I am waiting. Pipeline question, hazards question. Please respond. Students, what is the answer? Theory based questions. Already theory based questions explained so many in the OTS online test series. Okay, theory based questions are already present, MSQ based questions, right? So here we are mixing all cyan, okay? Yeah, Naman given, DGS given right answer. Naman, grow. Ritesh. Okay students, you all given the answers, so let us see. You know, this is the question related to the pipeline. So here RAW hazards, that is the true data dependency. Here comparison is what? In register, input register name is equal to output register name. Instruction J input register and instruction I output register. Okay, or else you can say source, not only register, source equal to destination. When source and destination both are matching, that is RAW dependency hazard. Okay, so true data dependency hazard. Especially when you know the concept, true data dependency means adjacent data dependency. Okay, so that is happen only in the in order execution. So default program execution is in order execution, so that always true data dependency is considered as a in order dependency between the adjacent instructions only. Correct? Fine. Now first, instruction 1, source is memory 3 of R1. Instruction 1 destination R0, instruction 2 source R0, so that I2 dependent on I1 with register R0, then I3 input R0 R2, correct? Now compare with the I2 output. It is not matching. It is not matching, but this is I3 to I1, it is matching, but already I2 is waiting, so I3 is also waiting. This is need not to be considered. Okay, all right. Next, I4 inputs R1 memory 3000, compare with previous matching. So here I4 dependent on I3 because of the memory. Source and destination matching. Okay, this we need to consider. Next, I5 inputs I4 output matching na, correct. I5 to I4, register R0, true data dependency. I6 inputs R3 R4, compare with previous, not matching. Then I7 input, compare with previous destination, not matching, R3 no. So total number of RAW hazards in the program 3 RAW hazards present. Next, WAR, this is out of order dependency, that is the output register name, or else you can say destination is equal to source. Destination and source both are same, then only dependency occurred. Now compare. I2 destination memory, compare with previous, not matching. I3 destination memory, compare with I1 and I2, not matching. Okay, then I4 destination R0, okay, compare with the inputs. Okay, matching. What is that? I4 anti-data dependent on I2, I4 anti-data dependent on I3 with the reference of R0. Then I5 output R2 compare with I1 not matching, I2 not matching, I3 matching, I4 not matching. So that I5 to I3 there is a anti-data dependency in the context of R2. Okay, so now I6 compare I6 output register. See this is output means memory. 8 of R1, that is output finally memory. Is it matching with any inputs? No, not matching. So no dependency. Then I7 output is memory 2000. Is it matching with any input? Memory 2000. Input में है क्या? नहीं है. So no dependency. So this is WAR. Next one WAW. WAW means what? Destination matching with destination. Destination both are matching. Now compare I2 with I1. I2 memory 2000, I1 R0 not matching. I3 memory 3000 not matching with I2, not matching with I1. I4 R0 output. Okay, so compare previously. Yes, matching. I4 to I1 in the context of R0 there is a dependency. Then I5 output R2 compare with previous outputs not matching. I6 output is memory 8 of R1 compare with previous memories not matching. I7 destination is memory 2000 compare with previous destinations, yes, matching. So I7 to I2 it is matching because of memory. Yes, this is about the dependency verification in the question. Okay, so now report the answer. What is mentioned? Anti-data dependency existed between I6 and I2. I6 and I2 anti-data dependency. I6 this is what? 8 of R1 anti-data dependency. 8 of R1, that means what? This is memory. See, R1 is the input. Then I2 this is I2 में this is R1, correct? So here final destination is memory, R1 is the input register. So this is the R1, this is also input register not matching. Input register matching, but that is not the anti-data dependency. Anti-data dependency means what? Destination and source both are matching. But here this is the register, this is also register. Both the registers are what? Input registers. Final destination is memory. That is the reason there is no data dependency, anti-dependency existed. False. Next, anti-dependency existed between I5 and I3. Yes, this is true. Output dependency existed between I7 and I2. Yes, this is true. Then in the code 3 RAW hazards present. So number of RAW hazards are 3 RAW. Yes, this is true. So in this question right answer is your answer. What will be the answer? B comma C comma D. This is the answer. How many of you given right answer? Please verify. Okay. Those who are missing the logic, please try to understand the logic. Don't repeat that mistake. Okay, students. A, B, D, the given. Here C is also matching, right? Memory same. So not only the registers comparison, actually here dependency means source and destination comparison. Harinder, don't compare only the registers, compare the source and destination. ओके ना, सोर्स मेमोरी डेस्टिनेशन मेमोरी दोनों मैच है तो सेम एड्रेस से, देन ओनली डिपेंडेंसी. memory same but address not same, therefore that is not a dependency. Is it okay? Any doubts? Naman, very good. Many are given the options, okay, in their option A is also present, but A is not present. See this, anti-data dependency existed between I6 and I2, nahi hai. I6 में destination is what? Memory. Memory address calculate करने के लिए this R1 is the input register. R1 is the input register, not the output register. Output of I6 is memory, okay, but here I2 में R1 is input register matching, source to source matching, that is not a dependency. Okay, that's what those who are given option A, that is wrong. You know, there is no anti dependency between I6 and I2. See, M of 2000 is the direct addressing mode, you know this. M of 2000 is the direct addressing mode syntax. Okay, then what about this 8 of R1, okay, or 3 of R1, these are the indexed addressing mode syntax. Indexed addressing mode syntax. Okay, so finally what is this meaning? Memory content of 8 plus R1, memory content of 3 plus R1, that is the meaning. So finally this is memory, but R1 is the input register. Finally destination memory, but input is the R1 register. That's what here they mentioned clearly. It uses the standard syntax. See this, standard syntax everyone knows. Okay, that is the reason this is the way to analyze the question. Okay students, please respond. कृतिका, समझ में आया? Got the things? Very nice. Now see the next question. All of you go through this question and give the answer. Please read the question quickly. Consider a program which contains 120 data transfer instructions, 160 ALU instructions, 100 branch instructions, executed in a 3 nanosecond clock cycle pipeline. है ना, पाइपलाइन में एग्जीक्यूट होता है ये प्रोग्राम. ब्रांच पेनाल्टी ऑफ द पाइपलाइन गिवन 4 cycles, ALU instructions penalty given 2 cycles. Branch penalty, ALU penalty given. Performance gain of a pipeline when the same program is running in the 2.3 nanosecond non-pipeline CPU with an average CPI of 5 is dash. Okay, program given that we are going to execute in the non-pipeline and also in the pipeline. Okay, calculate the performance gain. Do it quickly. I am waiting for your response. Yeah, answer please. Here program given, you need to execute in the pipeline and also in the non-pipeline. Report the performance gain. DGS, you given the answer. DGS from Kolkata. You are right. Remaining students, please respond. Okay. Right. Let me solve the question along with you. So here, first pipeline. In the pipeline, number of inputs n is equal to what is given? N is equal to 120 plus 160 plus 100. Right? So these are the number of instructions 120, 160 and 100. Right? So 120 plus 160 plus 100. These are the 380 instructions. But stalls in the program. How many stalls are present in the program? That is equal to, what is that? Here branch instruction creating the stalls, ALU instructions creating the stalls. So total 160 ALU instructions are there. Okay, into how many stalls? 2 stalls per ALU instruction, plus 100 branch instructions are there with a branch penalty. What is the branch penalty? 4 cycles, 4 stalls per branch. Okay, alright. So total stalls is equal to what? 160 into 2, 320 plus 400. So 320 plus 400, that become 720. Right? So total number of inputs is equal to 380 plus 720, that is 1100. So this is the finite number of inputs. When finite number of inputs, we are going to use the formula here, k plus n minus 1 into tp. This is the formula which we are going to use. But in this question, what is given? They missed the content or what? 3 nanosecond clock cycle. Yeah, here something is missing. 3 nanosecond clock cycle, 6 stage pipeline. 6 stage is missing. Is it okay? So when the n is a finite value, k is required. But in the question, k is missed. DGS. K value missed. So don't take your own k value. Is it okay? Alright. So now here k value is equal to 6. Actually that is missed. You just add it. 6 plus 1100 minus 1 into what is the cycle time? 3 nanosecond. 3 nanosecond clock. So 1100 plus 6 minus 1 into 3, that become 3315. 3315 nanosecond. Alright, next, execution time of non-pipeline execution time. So here n into Tn is the formula. So n, number of instructions 380 into Tn is equal to one instruction taking 5 cycles, each cycle taking 2.3 nanosecond. So here 5 into 2.3, that is 380 into 115. So 380, that is 4370 nanosecond. Now speed up. We need to report the speed up value. So speed up S equal to execution time of non-pipe upon execution time of pipe. So substitute this 4370 upon 3315. That is 1.31. Alright, so this is the way to solve the question. Okay students, so in this question number of stages missing actually. When number of stages missing, we cannot take we cannot take any default k value, correct? So here you need to consider 6 stage pipeline. Maybe they give 5 stage pipeline, 4 stage pipeline and so on, but here number of stages missed in the question. I added 6, so calculated output is 1.31. Okay students. Yeah. Sayan, how guys calculated without k value? I think students are assumed risk pipeline as a default pipeline. That's what they took k value 5. Sayan, samajh mein aaya? Some students already calculated. Okay, according to their imagination, default pipeline, successful pipeline, risk pipeline. They may take in k value 5 by default, but we are not going to assume k value by default 5. If they mention risk pipeline, then you take k value 5. So here some students are assumed default pipeline, risk pipeline. That's what they take in k value 5. Even question does not contain k value. But I say nahi lena. Okay, so here k value missed, I introduced k 6. That's what answer is 1.31. Okay, समझ में आया? Students, is it clear? Yeah, I know some of you taken the risk pipeline example. Very good. Now take next question. This is very simple question, right? But in the gate paper sometimes they are asking the small questions, right? Simple questions, so we are thinking that itna simple and small questions are not there. There may be some logic present in the question, like that we are overthink about the logic and the question, so finally we are giving wrong answers only. So don't overthink. Whatever the data given, follow that. Okay, so in the previous gate papers we have this kind of the questions also, correct? So you just read the question and give the answer quick. Question is what? Consider 6 stage pipeline with a respect to delay 2 nanosecond, 4 nanosecond, 6 nanosecond, 2 nanosecond, 5 nanosecond and 10 nanosecond. Correct? 6 stages, 6 non-uniform delay pipeline. 6 stage non-uniform delay. interface register used between the stages have a delay of 2 nanosecond. Interface register delay 2 nanosecond. What is the performance gain of a pipeline when program which contain 80 instructions is running in the pipeline over the non-pipeline? Okay, again calculate the speed up. Okay, program contain 80 instructions, non-pipeline and pipeline. Do it fast. Here no problem, number of stages already given. Answer? Yeah, many of you given the right answer, very nice, but still there is a small confusion here, because interface register used between the stages given, there is no interface register present at the end of last stage. Between the stages we have a buffer. Okay, some students are adding buffer delay to the last stage also. Okay, there your answer is wrong. Okay, another confusion is buffer is mandatory only in the pipeline, buffer is not required in the non-pipeline. Okay, for the non-pipeline execution no need of the intermediate results storage, so buffer is not required in non-pipeline. Okay, but some students are adding the buffer delay in the non-pipeline also. Okay, their students giving the wrong answer. If these 2 points are missed in the question, okay, your answer calculation is wrong calculation. Is it okay? All right. So here pipeline given, pipeline. Okay, k value, k is equal to 6. All right. Now cycle time is equal to maximum of stage delay plus buffer delay. That's it. Stage delay plus buffer delay. So this is max of stage plus buffer. What is that? What is the maximum here? 2 plus 2, 4 comma, okay, 6 comma, 8 comma, 4 comma, 7 comma, 10. Okay, there is no buffer at the end of last stage, no buffer. At the end of last stage. Okay, so this is 10 nanoseconds only. N equal to 80. 80 is the finite number. When the n value is finite, execution time is k plus n minus 1 into Tp. This is the formula. So k value, what is the k here? 6 plus n value 80 minus 1 into 10 nanosecond. Okay, so do the calculation. That is 850 nanosecond. This is the execution time of the pipeline. Now see the execution time of non-pipeline. Non-pipeline execution time. Non-pipeline execution time is equal to n into Tn. Okay, so n value already 80 into what is Tn? Tn equal to summation of stage delays. Stage delays. Okay, in the previous question, non-pipeline one instruction execution time explicitly mentioned, but in this question, okay, there is no special characteristics given for non-pipeline. So in the pipeline only we are executing the instructions in a non-overlapping order, one after another. So that's what one task execution time is, summation of all the stage delays. Okay, so now 80 into what is the delay here? 2 plus 4 plus 6 plus 2 plus 5 plus 10. So don't include the buffer delay. Okay, so 2 plus 4 plus 6 plus 2 plus 5 plus 10, that is equal to 29 into 80. That become 2320 nanoseconds. So pipeline time, non-pipeline time, both are ready. Now report them in the formula. Speed up S equal to execution time of non-pipe upon execution time of pipe. Okay, substitute 2320 upon 850. Do the calculation. 850. That is equal to 2.70. This is the answer. How many of you given this answer? That is the right answer. Okay, other than this, whatever answer you given, that is the wrong answer. Okay, identify where you did the mistake. Okay, students, clear or not? Respond. Santosh Kumar Yadav given right answer. Akash, Sayan. So many students given right answer. Narendra Kumar is the person who given right answer first. Narendra, so nice. DGS, you know, Yadav, you all are given right answer. Very good. Follow the same confidence, energy, tension free energy, stress free energy in the final paper also. Okay. Next question. Yes. This is operand forwarding question. Please read the question and solve it quickly. Students, do it fast. Okay, read the question. Okay, whichever the method you feel convenient, you please follow the method. Okay, in the regular notes I explained optimized method and fundamental method. Okay, fundamental method, manual method is drawing the space-time diagram or cycle diagram to solve the question. That is always fundamental method. Okay, then optimized method means calculating the stalls and report the value. So that is your choice. Do it fast. Yeah, students, what is the answer? Now here see the question. Question is what? Consider 5-stage pipeline. These are the 5 stages given. To execute the following code. This is the code given. Okay. Now dependencies. Verify. I2 dependent on I1. Then I3 not dependent on anyone. Then I4 dependent on I3. There is a dependency. Then I5 dependent on I4. Yes, there is a dependency. Correct? Okay, all instructions are spending one cycle on all stages, but mul takes 3 cycles, div takes 4 cycles on PD stage. Performance gain of a pipeline when the code is executed with operand forwarding over without operand forwarding. Now we need to calculate the gain. Okay, so we need to execute with operand forwarding and also without operand forwarding. Fine. Now see this. What is the pipeline given? 5 stages: IF, ID, OF, PD, WB. Everyone knows the definitions of this. I1, I2, I3, I4, I5. 5 instructions given. So every instruction spending one cycle like this on all stages like this, like this. Okay. Then PD, right? So addition takes 1 cycle, multiplication 3, division takes 4, okay, subtraction takes 1, multiplication takes 3, then remaining 1, 1, 1, 1. This is the given data. Later we are going to check the dependency. I2 dependent on I1, I4 dependent on I3, then I5 dependent on I4. Alright. So you know the optimized method to solve this question. I already explained. In the optimized method, with operand forwarding, without operand forwarding, what will happen? With operand forwarding. Here what you have? I1, 2, 3, 4, 5. So every instruction is taking one cycle to complete. One cycle, one cycle, one cycle, one cycle, one cycle. Now dependencies, right? So where exactly operand fetch happens, you need to verify. So this is the data read. Data read takes place in the OF. So हमको data OF में चाहिए, correct ना? So now here dependency, OF taking one cycle, PD, OF overlapping with PD, one cycle overlapped. Here data is available, therefore 0 stalls. Next, if you see the second instruction, third instruction, second instruction, no dependency. यहाँ ये दोनों का बीच में dependency नहीं है, still it is waiting. Why it is waiting? Because of the stays busy. This is taking 1 cycle, it is taking 3 cycles. No data dependency, but these are the structural hazards. Structural stalls. Everyone knows this. Now come to the next one. Here, I4 dependent on I3. Okay, here data dependency present, so that one cycle overlapping. So 3 stalls. These are the data stalls. Plus one cycle overlapping, data available. So 0 stalls. After that, if you see the remaining completion, here it is taking 3 cycles. Usually in the pipeline, every instruction spending 1 cycle, so that here 2 extra present. 2 extra cycles, don't say stall. 2 extra cycles required on PD stage. So total number of inputs n equal to, so here n is equal to 5 plus 2, 7, 7 plus 3, 10, 10 plus 2, 12. This is finite. When it is finite, execution time is equal to k plus n minus 1 into TP. Cycle time given or not? Here cycle time not given, so answer is in a form of cycles. So 5 plus 12 minus 1, this is equal to 16 cycles. Yes, correct. This is the execution time with operand forwarding, optimized method. Okay, then without operand forwarding, what will be the answer? See, without operand forwarding. Okay, so take the instructions here: I1, I2, I3, I4, I5. Okay, so every instruction by default taking one cycle, 1C, 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 1C. Now dependency, I2 dependent. Okay, data हमको OF में चाहिए, OF overlapping with PD. When data available here, no stalls. But हमको data कहाँ available होता? PD के बाद WB and next cycle. Here data read happens. Data read happens after completion of the WB stage without operand forwarding. Is it okay? All right. So now 1 plus 1. Here one overlapping with 1 extra. This is 1 and next cycle is 1. 2 cycles, 2 stalls. Next I3. I3 is not data dependent. It is waiting for the stage so that 2 stalls. These are the structural stalls, not the data stalls. Okay. Then I4. I4 के लिए data चाहिए, you know, where the data is available, right? So 1 cycle overlapping with 4. Here extra cycles 3 plus 1 and here data available. So total 5 stalls. 1 cycle overlapping with 4 extra 3. 1 overlapping 3 extra plus 1 4. Next cycle 5. Clear na? Right. Next I5 data हमको चाहिए that is available after WB. So 1 cycle overlapping extra 1 plus 1 2 stalls. After 2 stalls, if you see this 3 cycles, PD taking 3 cycles, so 2 extra cycles required. 2 extra cycles required. This is the way to identify the stalls optimally by using with operand forwarding and also without operand forwarding. So now number of inputs n is equal to, specify n value, 5 plus 2 7, 9 plus 5 14 plus 4 18. So n is 18 is nothing but a finite. Okay, so now apply formula, execution time k plus n minus 1 into tp. So k value 5 plus 18 minus 1 cycles, tp not given, cycle time not given. So what will be the answer? 22 cycles. Am I correct? Right? Then what the question expecting? Performance gain. So speed up s equal to execution time without operand forwarding and execution time with operand forwarding. Okay, so S is equal to value please 22 upon 16. Report the final. 22 upon 16, that is equal to 1.375. Okay students, how many of you given right answer? Please tell. Students, this is the discussion, right? Already you know this type of calculation in the regular class. So in the regular class I explained how to solve the question without drawing the table also. That is this. Okay. So those who are the MADEZ students, they know these shortcuts. Okay. So otherwise you need to draw the manual diagram. How 2 stalls, how 1 stall means, that depends on the overlapping condition. I saw. Pipeline means in every stage, every instruction spending one cycle. Okay. So when it is overlapping, one cycle is overlapped and remaining cycles are the extra cycles. Those extra cycles are the stall cycles. Clear? DGS, your answer apt. Naman. Okay, Santosh Kumar Yadav, very nice. You all are given the right answers. Okay, so here I am not going to draw the table. Okay, drawing the table and solving the question, it will take a bit time. Okay, so whichever the method you feel convenient, you can apply. It's not an issue. So some students are asking how 12. 12 means number of inputs. Number of inputs are 5. See this, number of inputs 5 plus number of stalls. Stall is also one input in the pipeline. Stall itself is input in the pipeline. Therefore 5 plus 2, 7, 7 plus 3, 10, 10 plus 2, 12. 12 is this. Stall itself is input in the pipeline. Every cycle in the pipeline is one input. Okay students, any doubts please? Those who are watching live, okay, those who are watching live, if you have any doubt in this question, please respond. Otherwise we'll move on to next question. Please give the response. Okay, Shivam, you are asking how 12. 12 is like this. Stalls calculation. शिवम कुमार गुप्ता, 12 साइकिल्स कैसा है विथ ऑपरेंड फॉरवर्डिंग? If any student having the doubt in this, you please draw the diagram and a table wise also you may calculate. Okay, that answer also exactly matching, but table wise calculation, drawing the space time diagram, cycle diagram, it will consuming time and also takes space. That's your choice. Right, next question. Shall I move? Right. Yeah, this is the next question. All of you read the question. Pipeline question again. Respond. Students, question ready? Read the question. What the question says: consider 6-stage pipeline used to execute the program which contain 30 instructions, I1 to I30. I6 is an unconditional TOC. It transfers the control to I24 during its execution. In the pipeline, target address is available in 4th stage. All stages are balanced with 3 nanosecond clock. All stages balanced with 3 nanosecond clock. Amount of time saved using the branch prediction over without branch prediction to complete the program. Okay. So with branch prediction, without branch prediction. With branch prediction means what? Target address present in the first stage only. Without branch prediction means target address not present in the first stage. Then where the target address present, they given 4th stage may present. Okay, all right. What is the answer? I'm waiting. Please respond. Yeah, Shivam, Mighty, Santosh Kumar Yadav. Thank you. You all given right answer. Now let us see what is the solution. So here with prediction, with prediction. With prediction means what? No stalls, because target address is in फर्स्ट स्टेज में हमको टारगेट एड्रेस मिलता है, दैट्स व्हाट नो स्टॉल. सो नंबर ऑफ इनपुट्स I1 to I6. ओके, आफ्टर दैट विदाउट स्टॉल्स 0 स्टॉल्स प्लस डायरेक्टली इट इज मूविंग टू वेयर I24 टारगेट एड्रेस I24 to I30. so number of inputs here 6. okay, 24, 25, 26, 27, 28, 29, 30. Here 7. So 6 plus 0 plus 7. This is equal to 13. So n is equal to 13. 13 is nothing but a finite value. When it is finite, use execution time formula. K plus n minus 1 into Tp. So 6 plus 13 minus 1 into Tp. Tp is 3 nanosecond. Report that. Do the calculation. Right. So this is a 54 nanosecond. Right. Next, please. Without operand forwarding. Sorry. Without prediction. Where the target address available? So I am just solving this as a manual procedure. Okay. If you want to solve this question directly, number of stalls calculate करके, directly multiplied with a cycle time, that will be the answer, because inputs are same, except the stalls. Once you know number of stalls, multiply with the cycle time, that is the final answer. Those who are comfortable with the entire logic, directly they came to the conclusion. If I explain that conclusion directly, some of the students are fade out. That's what I am taking the manual procedure. Correct? Still, to get the comfort zone in the respective area. Okay, right, please. So I1 to I6 plus, right, how many stalls? That is fourth stage में हमको target address मिलता है -1, that is 3 stalls. Right. Next I24 to I30. That's it. So here 6 plus 3 plus 7, that becomes 16. n is equal to 16. So take the difference. वहाँ 13, यहाँ 16. Remaining are same. Difference is 3. 3 into cycle time 3 nanosecond. Total 9 nanoseconds time is saved. Straight away you can give the answer. Otherwise, execution time. K plus n minus 1 into Tp. So 6 plus 16 minus 1 into 3 nanosecond. Do that. 6 plus 6 minus 1 into 3, that is 63 nanoseconds. Okay, now amount of the time save equal to 63 minus 54, that become 9 nanoseconds time is saved. Already students given the right answer. Very good. Okay, you all are given right answer. So why I explain like this, many students are they don't know the complete logic. That's what I explained like this. So those who know the concept, they identify the stalls, multiply with cycle time, that will be the answer. Very nice. Okay students. Now next question please. Yeah, this is the question. All of you please read the question, do it quickly. Students fast. This is a cache memory question. Narendra, DGS, please solve it. I am waiting for your response. Do it fast. Right. See the question. What the question says. Consider 64-bit hypothetical CPU supports 32 KB cache organized into 64 word blocks. Okay. Cache memory data is a subset of 2 power 34 bytes. In each line of a cache, one valid bit, one update bit is present apart from tag space. Which of the following statements are correct? We need to identify the correct statements. Okay. So when you see the options, in the options all the variations present in the cache given. Direct cache is there, associate, fully associative is there, set associative is there. That too 4-way set associative is there, 16-way set associative is there. So nowadays, okay, in the exam paper this kind of lengthy questions are present. Okay, the way how you are going to answer that question within the less time, that gives the your rank improvement. So you please implement the logic, solve the question quickly, fast. Santosh Kumar Yadav, what will be the answer? See here in this question, main memory given, cache memory given and block size given. Main memory 2 power 24 bytes, cache memory 32 KB given, block 64 words given. See, already main memory is in bytes, so that cache memory is in bytes. When cache main both are in bytes, this block is also supposed to be there in bytes, but this is in words. So convert that 64 into 64-bit word, that is 64 into 8 bytes. Okay, 2 power 6 into 2 power 3 bytes, that become 2 power 9 bytes. So now block is also present in the compatible format. Am I right? Okay. So now take the structure and report the answer. So 64-bit CPU is there. Now 32 KB cache is there, CM. Then what you have? 2 power 24 byte main memory is there. Yes. So this is the discussion. Here block size is equal to 2 power 9 byte block. Now apply the mechanisms of the mapping. So here number of lines is equal to 32k upon 2 power 9, that is 2 power 15 upon 2 power 9, that become 2 power 6. 2 power 6 lines are there. Here 34 bit, no? 2 power 34. Main memory 2 power 34, not 24, 34, right? So here 34 bit physical address is there. 34 bit physical address, main memory address. Now report the values. Do the further calculation. I am waiting for your response. Yeah, Naman, 2 power 34. That is the main memory capacity. Okay, so first direct mapping. What they mentioned? Direct mapping. See, first take direct mapping concept. Direct mapping. Address format 34 bit physical address divided into tag, line offset and word offset. So log block size 2 power 9 base 2, 9 bit. Then log 2 power 6 base 2, that is 6 bit, and remaining bits are used for the tag. So tag is equal to 34 minus 6 plus 9, that is equal to 19 bit. 19 bit tag space is there. So when it is 19 bit, what it mean? What it mean? 19 bit tag space is there. Matlab in each line 2 power 19 main memory blocks are possible to map into a cache line, one at a time. This is the meaning. This is the meaning, correct? Tag space is 19 bit. Matlab 2 power 19 main memory blocks are possible to map in each line of a cache, but one at a time. So severity of the thrashing, okay, will be depends on the 2 power 19 blocks reusable cases. Okay, if tag space is 1, only 2 main memory blocks are possible to come in the same line. Tag space 2 bit, so 4 main memory blocks are possible to map in each line. You know that logic. So here tag space 19 bit, so that 2 power 19 main memory blocks are possible to map in each line, but only one at a time, because direct mapping. All right. Right. So when you see the first question, see this first option, in direct mapped cache line can able to hold only one block of 2 power 19 possible blocks. This is true matching. Next case. What the next case given? Associative. They given fully associative. What is associative cache? See this. In the associative cache, address format is 34 bit address, become tag and line offset, word offset. 9 bit is word offset. So 34 minus 9, that is equal to 25 bit. Is it okay? Therefore tag memory size, they given question statement, tag memory is equal to n into number of lines into tag space in the line. that is 2 power 6 into 25 bit. Okay, 2 power 6, 64 into 25, that is 1600 bits. Okay, if you see the question, in the question what they are expecting, set associative cache design tag directory is 216 bytes. So we want bytes. See this, 1600 upon 8. Okay, but in this case what is given? Tag space in the line. Here one valid bit is there, then one update bit is there, question may given. Okay, so here total value is not 1600, 64 into 27, that become 1728. Question expecting the answer in bytes, so divided by 8, that become 216 bytes. Okay, now if you see this option, this is also matching, correct. All right, now see the next one. Next question is what? 4-way set associative cache. See this, 4-way set associative cache, tag directory 168 byte. Now see, 4-way set associative. Four-way set associative, that is S is equal to n by p way. So n is 64 upon 4, 2 power 6 by 2 power 2, that become 2 power 4. Am I right? So now address format, this is the 34 bit, dividing into tag, set offset and word offset. Word offset is 9 bit. Now set offset is 4 bit. Remaining bits are the tag. 34 minus 13, that is 21 bit tag space. So tag memory is equal to n into tag space in the line, that is 64 into tag space, 21 plus 1 bit plus 1 bit. Okay, so do the calculation. 64 into 23, 1472 bits, divided by 8, that become 184 bytes. Do the calculation. Okay, but when you see the option, in this option what they given, tag memory size is 168, but that is not matching, this is wrong. Fine. Now 16-way set associative, also given 16-way. So here we are taking 16. Way set associative. It's a lengthy question, okay? S equal to 64 upon 16, that is 2 power 6 upon 2 power 4, that become 2 power 2. So format, address format 34 bit. So now tag, set offset, word offset. Word offset 9 bit, set offset 2 bit, and remaining bits 23 bit tag space. Okay, so now tag memory size equal to number of lines 64 into tag space 23 plus 1 plus 1, 1 valid bit, 1 update bit. So 64 into 25, 64 into 25, that is 1600 bits. But question is expecting in bytes, so that become divided by 8, 200 bytes. Okay students, so 16 bits set associative cache, tag memory size is 200 bytes. Now go back to the question. See the question. In this question what they mentioned, in 16-way set associative cache, tag directory 200 bytes. Yes, it is matching. So in this question right answer is A comma B comma D. A, B, D is the right answer. Let me see how many of you given right answer. Okay, so in this question all the three variations are covered. Yes, listen, actually nowadays in the exam paper they given the lengthy questions only to filter out the students. Okay, even it is lengthy, when you are conceptually strong it is easy to solve the question. Okay, when you are conceptually strong, directly format and calculation ऐसा हम कर सकते. If you see the PYQs, their lengthy questions are formulated in the recent years of the GATE paper. If you see, there we have the lengthy questions to filter out the students. You know, those who are conceptually strong, they only capable to answer this kind of the question. Even one question is also changing your rank a lot. That is the reason, be strong with all concepts, because question paper is unpredictable, right? Very good. So still students given right answer. Kritika, DGS, okay, Premium Gaming, I don't know what is the name, exact name, Narendra, you all are given right answer. Okay, all right. Now go to the next question. Yes, this is the question, memory question. Yeah, this is the question. All of you please read the question and solve the question. What the question says: consider 3 level memory, level 1, level 2, level 3. Hierarchy design given. Level 1 memory 8 times faster than level 2 and level 2 memory 4 times faster than level 3. Hit ratio of level 1, level 2 given 70% and 80% respectively. Okay, access time of level 3 given 800 nanosecond. What will be the average memory access time? Okay, so when you remember the formula, then you are in a position to answer the question. 3 level memory hierarchy formula. Hierarchy given, therefore hierarchical organization. Okay, now it's a formula based question. All of you please substitute the data in the formula and report the final answer. Do it quickly. Students, answer ready? Yes. Narendra given the answer. So see this here, 3 level memory organization given. Level 1, level 2, level 3, hierarchical memory given. So here H1 comma T1, H2 comma T2, H3 comma T3. Okay, so you know that H1 is given 70%, H2 given 80% respectively. Then last level memory hit ratio is always 1, right? Now level 1 memory 8 times faster than level 2. So S is equal to T2 upon T1. Okay, so here what is this? S is equal to 8 times faster than, like this. Level 1 memory 8 times faster than level 2, and level 2 memory 4 times faster than level 3. So here S is equal to T3 upon T2. So now S4 is equal to T3 upon T2. Is it okay? Let T3 is equal to 800 nanoseconds. Therefore T2 is equal to what? T2 is equal to 800 divided by 4. That is equal to 200 nanoseconds. Okay. Now T1 is equal to what? 200 nanoseconds divided by 8. 200 nanosecond divided by 8, that is 25 nanoseconds. Okay students, they are given clearly. This is the representation. Now apply them in the formula. So T average is equal to 3 level T1 into H1 plus 1 minus H1 into H2 into T2 plus T1 plus 1 minus H1 into 1 minus H2 into H3 into T3 plus T2 plus T1. This is the formula. Substitute that and report. 0.7 into 25 plus 1 minus 0.7 into 0.8 into 225 plus 1 minus 0.7, 1 minus 0.8 into 1025. T3 plus T2 plus T1. Now simplify the formula. To the calculation, 17.5 plus 0.3 into 0.8 into 225, that is 54 plus 0.3 into 0.2 into 1025. 1025, that is 61.5. Final answer 61.5 plus 54 plus 17.5, that is equal to 133 nanoseconds. This is the answer. Okay students, 3 level memory hierarchy answer 133 nanosecond. Okay, Narendra, you are the first person who given the right answer. DGS, second person. Santosh, here your rank is 5. Matlab fifth person you given right answer. Naman third person, Shivam fourth person, right? So whoever the students watching live session, they are calculating and they are giving the response. Okay, maybe according to your network speed, that transmission may happens, right? Anyway, conclusion is what? You all are given the right answers. Feeling very happy, very nice. Okay students, okay, next question. Yeah, this is the question again. So random based questions, right? So suddenly we are moving back to instruction formats. All of you read the question, give the answer. Students, carefully read the question. What's the answer? I am also reading the question, you just see this. Consider 24-bit hypothetical CPU which support one word instruction placed in 4 KB memory. Register file size 32 with register width 24 bit. Number of registers are 32. In each register 24 bit space is present. System supports 3 address register reference instructions, 2 address register and memory reference instructions, and 1 address memory reference instruction. See this? 3 address register reference, 2 address register and memory, and 1 address memory instruction. If there exist 30 3 address instructions, 120 2 address instructions, then how many 1 address instructions can be formulated? Okay, so this question belongs to the expand opcode technique. So solve the question, give the answer quick. Please see, every question I am solving, Guru. Whatever the questions I explained, I display the question, I am waiting for your response. Later I am solving the question along with you only. Okay, so it's an expand opcode technique question. So how to solve it? Please solve quickly. Here CPU is equal to 24 bit CPU. Therefore, word length is equal to 24 bit. The given instruction size is equal to 1 word. That is equal to 24 bit. Okay. Formats given. What are the formats? 3 address. Okay. 2 address. And 1 address. Aisa diya. So all the 3 different formats of the instructions having the same length, fixed length. Fixed length instructions में different formats design करना चाहिए तो expand opcode technique use करना पड़ेगा. So use expand opcode technique. Okay, right. So by comparing the primitive and derived opcode difference, we are merging. That is the expand opcode technique. So now see this 3 address format. What is given? 3 address register reference. 3 address register reference means what? There is a opcode and register, register, register. This is the format. All the 3 addresses are register addresses. Next is 2 address register and memory reference. Register and memory. So here opcode, register and memory. This is the structure. Then 1 address memory instruction. What is the format? 1 address means opcode, address में memory. This is given according to question. Now format sizes पता कर लो. This is 24 bit. Register 32. So 5 bit, 5 bit, 5 bit. Okay. Right. Now remaining 9 bit opcode. Again 24 bit instruction. 5 bit and 12 bit. 5 bit and 12 bit. 17. Right. Remaining 7 bit opcode. Right. Next 24 bit it is. So memory 12 bit, opcode 12 bit. Aisa we taken the formats. Am I right? All formats. Okay. So now here we are comparing the opcodes. Smallest opcode is the primitive. This is the smallest. Smallest is the primitive opcode. Next small is the derived, and next is the further derived. Like this we are solving. Is it okay? So first design the primitive, later take the free space, okay, compare the opcode difference, okay, merge the bits. So ये दोनों का बीच में opcode difference is how much? Primitive 7 bits and 9 bits, 9 minus 7, so 2 bits we need to merge. Then 9 and 12, 12 minus 9, 12 minus 9, 3 bits we need to merge. So here 3 bits merge करना पड़ेगा, here 2 bits merge करना पड़ेगा. This is the expand opcode technique concept. Okay, so now first take the to address. Primitive format is to address format. Opcode and register and memory. So now here this is what? 7 bit, 5 bit, 12 bit. So 7 मतलब number of operations equal to 2 power 7, that become 128. 128 operations present. Is it okay? And after that what is left? Number of free opcodes is equal to 128 minus how many are present? 120. This become 8 free opcodes. Now use them for 3 address. So number of 3 address instructions possible. Number of possible is 8 into how many bits we are merging? 2 bits we are merging. Difference between the derived and primitive opcode. So 2 power 2. So this is equal to what? 32. Number of free opcodes. Right? After 3 address instructions. So 32 minus how many? 30 instructions. That is 2 free opcodes. These 2 free opcodes are used for 1 address memory instructions. Number of mod address memory instructions possible. 2 free opcodes into how many bits we are merging? Opcode difference. Opcode difference is 3 bits. 2 power 3. That become 2 power 4. 2 power 4 is nothing but 16. So 16 1 address memory reference instructions are possible after implementing the 33 address instructions, 120 2 address instructions. Okay students, how many of you given right answer? Yes, Narendra, you all are given the right answers. Very nice. Yeah, Guru, you are sending the question. If you have any doubts, personal doubts, you please send the questions to my WhatsApp, okay? Yeah, Shivam, Narendra, Anil, you all are given right answer. Yeah, students, if you have any doubts related to the subject, and you want any additional questions, you please send those questions to my WhatsApp, right? So we will discuss there, right? Especially for the Made Easy students, they know my WhatsApp number. Is it okay? Right, now see the last question, DMA related question. I just written the DMA related question. So all of you please solve this question. Read it first of all. Guru, you type the question in the chat. Okay. So you sent that question to me. Are you have the number? Right. If you are a Made Easy student, you have my number. So you please send that question to my WhatsApp. We will discuss there. Okay. All right. Consider 64 KB data file transferred from IO to main memory using DMA. We are going to transfer 64 KB data file. Okay. 10 Mbps IO device is connected to 32-bit CPU using DMA interface. Okay. DMA contain 32-bit data register and 10-bit count register. Okay. Number of times DMA steal the control of system bus from CPU to complete the data transmission. How many number of times DMA steal the control of a system bus to complete the transmission? That means we need to count number of DMA cycles. How many DMA cycles are required to complete the data transmission? Okay, please solve the question. Okay, so here when you see the logic of the DMA, by default DMA mode is the burst mode. By default DMA mode is burst mode. So in the burst mode, data transmission is controlled by the count register. Until count register becomes 0, system bus is in the hand of DMA. Okay, in each counter one word data will be transmitted. Correct? So in this question, count register size given, but count register initialization not given. So here 10-bit count register is there. So total number of counts are 1024. Therefore, in one DMA cycle, 1024 words are transmitted. Okay, what is the word size? That is 32-bit. So 1024 words means 1024 into 4 bytes, that is 4 KB data transmitted in one DMA cycle. Like that, how many DMA cycles are required to complete the overall file transmission? Okay, so file size divided by amount of data transmitted in one DMA cycle. If you use this, you get the number of times DMA steal the system bus from the hand of CPU. Correct? So here solution is count register is equal to 10 bit. So 2 power 10 counts possible at the maximum. Therefore 2 power 10 words are transmitted in one DMA cycle. In one DMA cycle, 2 power 10 words are transmitted. Okay, therefore, amount of data transmitted per DMA cycle is equal to 1024 words. That become what? 1024 into 32 bit. Okay, so this become what? 4 KB, right? Then how many DMA cycles required? That is equal to 4 KB data transmitted in one DMA cycle. Then 64 KB data transmission के लिए how many number of DMA cycles required? So this is equal to 64 KB upon 4 KB. Okay, 64 upon 4 KB. Answer is 16 times. Okay students, so DMA steal the control of a system bus from the hand of CPU 16 times. Okay, all right. Narendra, Naman, you all are given right answer. Okay students, these are the questions which we are going to refresh in this session. So hope that we all covered all the major areas which are present in the COA subject. Okay, right, this is the information, that's it. So in this GTQ session of computer organization and architecture, we covered some set of the questions which are related to the different areas of a computer organization and architecture. Okay students, thank you all the best. God bless you all. Take care. Bye bye.